NCERT Physics Class 11th, 6th chapter, which is Work, Power and Energy, and question number 6.2. So in this, a body of mass 2 kg initially at rest, initial velocity is 0, under a constant, under the action of applied force, which is 7 Newton on a table, with coefficient of friction mu is equal to 0.1. In this, we are supposed to find out the first part, work done by the applied force in 10 seconds. So we have to find the work done by applied force in 10 seconds. Moving to first part, which is A. So as we all know, the applied force is 7 Newton, which is constant, and the work done by constant force can be written as F dot S, where theta is F dot S can be written as Fs cos theta. Theta is angle between two vector, which is F and S. So in this, we are supposed to find out displacement first. So let us look to the problem. A block is placed on the table and the horizontal force, which is equal to 7 Newton, is applied. So as we all know that due to the frictional force on this surface, a frictional force will also act, and that the value of this frictional force is equal to mu into N. So the net force can be written as F net is equal to M into A. Net force can be written as 7 minus friction in the net force can be written as 7 minus friction, and this can also be written as mass into acceleration. So from this, by putting the value of friction, we can find out the value of acceleration of the given block. Now friction is equal to mu into N. The value of mu given to us is equal to 0.1, and normal is equal to M into G. The mass of the block is 2 kg. So the normal can be written as M into G, which is equal to 9.8. So from this, we can have the value of friction is equal to 1.96. So from this, we have the value of friction as 1.96. Now putting the value of this friction, the equation of force net force, we can find the value of acceleration, at 7 minus friction, which is 1.96, is equal to mass, which is 2, into acceleration. On putting this value, we have acceleration, which is equal to 2.52 meter per second square. Once you attain the acceleration, you can find the value of displacement. Acceleration is constant, so we can apply the equation of motion. Equation of motion, that is equal to S equal to ut plus half at square. Initially, the particle is at rest, so we can say that displacement of the particle is given as S equal to ut plus half at square. So in order to find the displacement for 10 seconds, initial velocity is 0 as particle is starting from rest. So displacement can be written as half acceleration, which is equal to 2.52 into t square, that is equal to 10 whole square. On solving this, we get the displacement, which is equal to 126 meter. So as we all know, in this situation, the force is applied toward the right and the displacement also take place toward the right. So angle between the force 7 Newton and displacement is 0. So work done can be written as Fs cos theta. So coming to part A, we can say that this work done can be written as Fs cos theta, that is equal to Fs, as theta is equal to 0. So cos theta would be 1. The value of F given is 7 Newton and the displacement comes out to be 126. So in this, the work done comes out to be 882 joule. Moving to B part, in this is a work done by the friction. So as we all know, the friction force is acting this direction and displacement is this direction. So theta is equal to 180. So work done is equal to friction minus of friction into displacement. Minus of frictional force into displacement. Minus is due to as theta is equal to 180 degree, which implies that work done can be written as frictional force which was 1.96. So minus 1.96 into displacement, which is equal to 126 meter. So on solving this, we have frictional work which is equal to minus 247 joule. C part is asking about what is the net force, work done by the net force. Work done by net force means total work. Work done by net force is can also be written as total work done. And from this we can say that work done total is equal to summation of all the work. So work done by external force which is equal to 882 and work done by friction is minus 247. On solving this, we have total work which is equal to 635 joule. The last part D is asking about change in kinetic energy in 10 seconds. So as we all know, the work energy theorem, which is equal to work done is equal to change in kinetic energy. So total work done is equal to change in kinetic energy, and we have total work done is equal to 635 joule, which is equal to change in kinetic energy in 10 seconds. As we have taken the work done of 10 seconds, so this is change in kinetic energy for 10.